So hello everyone. Today we are going to learn how to convert binary code into gray code using ARM7 assembly language on the LPC2148 microcontroller in Keil Vision. First of all, what is a gray code? Gray code is a special binary numbering system where only one bit changes between consecutive values. This is useful in digital electronics because it minimizes transition errors. Consider this example of binary to gray code conversion. Now let us understand the core logic of binary to gray. Suppose a binary input is 1101. To convert binary into gray code, we use XOR between adjacent binary bits. That is, the gray bits are generated as G3 is B3, G2 is B3 XORed with B2, G1 is B2 XORed with B1, and G0 is B1 XORed with B0. Now let's see step by step mathematical conversion. Our original binary data is 1101. In order to calculate G3, we have to just check what exactly is the value of B3. It is 1. Next we need to calculate G2. To do that we need B3 and B2 and the result we obtain is 0. Next we calculate G1 where we XOR B2 and B1 and the result is 1. Next we calculate G0. Here again we XOR B1 and B0. So the result is 1. In this way we obtain the final gray code which is 1011. So binary 1101 corresponds to gray code 1011. Now let's see how the ARM7 code implements this. Instead of calculating each gray bit separately, ARM7 uses a shortcut. We shift the binary number right by one position and XOR it with the original binary number. So mathematically, gray code is obtained by XORing binary data with the same binary data right shifted by one bit position. This single operation automatically performs all adjacent bit XOR calculations in parallel. Now let's see our actual code. At first let's check if this code has any errors. No errors, so we'll go ahead with debugging. First let's understand what's happening here. Area is an assembler directive which defines a section of memory to store this information. Binary to gray is the name I have given to that section of memory. Code indicates this section of memory contains instructions. Read only because we don't want any modification to be happening to the code during runtime. Entry indicates where exactly execution starts. Execution starts at the very first label after entry. Start and stop are nothing but labels. End indicates the end of source file. At first we load our desired binary data into register R0. In hexadecimal it's the value D. Next we are performing logical shift right on this particular data by one position and storing it in register R1. The result we obtain is 6. Now we perform our actual XOR operation and store its result in register R2. The result we obtain is B. This is our desired gray code. Then we jump to an infinite loop, stop, branch to stop. So for the binary code 1101, the gray code output will be 1011. That's all about this code.